Hello, welcome. We're going to be looking at something very similar to what we did yesterday in class. Yesterday we looked at molarity, which is a way of measuring concentration. Today we're going to be looking at something very similar name, molality, with an L instead of an R. So everything's going to be very similar to what you were doing yesterday. Please, as we're going through this video, feel free to pause things at different times. Give yourself a moment to write things down. Because if you have some nice notes, it'll be very helpful when you go on to do your assignment. So molality is going to be, for its unit, it's little m compared to molarity was a capital M. So they're very similar, and how we find them and everything about them is also very similar. So it's going to be molarity was the moles of our solute divided by the liters of solution. Molality is going to be the moles of our solute again, but this time divided by kilograms of solvent. So a very similar process. I'll take a look at a couple of examples, basically the two ways that you would have to work this out. One where you're given the molality to start with, and we're trying to find how much solute, and the other one where you're given how much solute, and you need to find the molality. Those would be the two cases, the two things you'd have to deal with as you work with molality. So for our example, first one we're going to look at, we have a 2.3 little m, so a 2.3 molal solution of calcium hydroxide. Is made with 1.34 kilograms of water. How many grams of calcium hydroxide were used? So we'd have to figure out, we're given the concentration, molal, and we're given our kilograms. So if you look at that equation from the last slide that we just went over, we know the molality, we know the kilograms, so we can plug in 2.3 for the molality on the left side of that equation. On the top would be the moles, and on the bottom would be the kilograms. And I don't know the moles, so I just put an N there to represent that. And we're given 1.34 kilograms. So we got that set up there. We just plugged those two in to the equation we just wrote down for molality. If we want to find moles, we'd have to multiply, cross multiply. So we'd have 1.34 times 2.3. That would tell us N, the number of moles. So if you hopefully have a calculator so you can do this as we work it out. If you don't, maybe pause, go grab one. We do that, we multiply those two. That would give us 3.082 moles if we just keep a few digits on there. So that's our moles, 3.082 moles. We're going to have to figure out how many grams. I didn't give you a chemical formula on this one, so we'd have to figure out what is calcium hydroxide. Maybe take a moment, look at your periodic table, look at your polyatomic ion chart on the back of your packet. What's calcium and its charge? What's hydroxide and its charge? Calcium is 2 plus because it's in the second column. Hydroxide is -1. And we cross those charges, we get CaOH2, which we'll need because we're going to have to do our bridge here. We're going to have 1 mole will go on the bottom to cancel out our moles. Grams is going to go on the top. And where are we going to get those grams? How are we going to find that number? Yeah, you're right. We're going to look at the periodic table, and using this chemical formula, we're going to have 1 calcium, 2 oxygens, so O times 2 and H times 2, and we'll add those 3 up. 2 oxygens, 2 hydrogens, 1 calcium. Add that up. If you do that correctly, that should give you a little bit over 74.0918 grams. That's on the top, 1 mole on the bottom. So we do 3.082 times 74.0918. That will give us our mass, our grams, 228 grams of calcium hydroxide. Right, so that would be one setup, one pattern you'd be following as you work out these molality problems. If you're given the molality to start with, this is basically exactly what you'd be doing with just some different numbers, but the same exact process. The other way you'd work it out is if you're trying to find the molality. Let's say in this case, we're looking for what is the molality. If we have 84 grams of lead 2 nitrate in 400 grams of phenol. So in this case, one thing that's a little bit trickier maybe here than it was with the molarity is that both of the numbers we're given to start with here are in grams. Before we had like one was probably grams and one was either milliliters or liters, so it was obvious which one was our volume, our liters, and which one we needed to figure out moles for. But here, we have 2 things that are in grams. One of them is going to be converted into moles, and one of them will be converted into kilograms. How do we tell which one we want to do which? Probably the easiest way, if you want, is if you just look at it, whichever one is the larger number of grams. It wouldn't be guaranteed, but basically anything I will give you in class, yes, that'll be the case. The one that's the larger number of grams is the one you want to do kilograms for. That would be the solvent that you're mixing things into because you have more of it, and you convert that to kilograms. So in this case, that'd be the 400 grams of phenol. And if we want to convert it to kilograms, how many grams are in a kilogram? Yep, that's 1,000. You're right. Of course, I know you answered along. You probably spoke out loud, and other people are looking at you funny. So there are 1,000 grams in 1 kilogram. So we'd be dividing by 1,000. 400 divided by 1,000, moving the decimal place over 3 spots, give us 0.4 kilograms. It's just like when we have milliliters and we're converting to liters, we'd be dividing by 1,000. Same thing, grams to kilograms, divide by 1,000. So that's always going to be the case for anything we're doing in this chapter when you're converting the grams or milliliters into kilograms or liters. That makes it nice. Always dividing by 1,000 for stuff. The other one now, we need to get our 84 grams of lead-2 nitrate. We're going to convert that into moles. That'll be our bridge. So we do need to know what is lead-2 nitrate, what is its chemical formula, so we can do its molar mass. So lead-2, that 2 there, that Roman numeral is telling us the charge of lead, Pb2+. Nitrate, it's got that 8 ending, that'd be on the back of your packet, one of our polyatomic ions. You would look that up. You'd find it on the back, it'd be NO3 negative. And if we cross the charges, bring that 2 across and over, we'd have PbNO3 2. So when we get our molar mass, so that we can convert to our bridge, we're starting with 84 grams. So grams is going to go on the bottom of that next step, and that'll be the grams off the periodic table for if we take our 1 lead, our 2 nitrogens, N times 2, and our oxygen times 6 when we put those together. 3 times 2 is 6. We add all that up, 1 lead, 2 nitrogens, 6 oxygens. I add that up on our calculator and do that correctly. You get about 331.208 grams. That's on the bottom because we had grams. So then we are going to divide. And if they do that correctly, they'll give us 0.25 moles if we're doing 2 decimal places. So that's our moles. What is the molality of our solution? If we look back when we wrote that down, molality is the moles per kilogram, the moles of solute divided by kilograms. So we'll take 0.25 and divide it by our 0.4 kilograms. And if we wanted to do, let's say, 3 decimal places for our final answer here for molality, that would give us 0.625 little m for molality. All right, so very similar to the molarity. Very, very similar. So hopefully that wasn't too bad. Take a look at the assignment. If you are getting stuck on one, you can feel free to pull this video back up and rewatch whichever example matches up best with the one you're doing right there, and that could help you out a lot. So feel free to do that. Good luck. Do some good work, and we'll talk to you later.